A cap is equals to 0.8 I cap. 0. Samira, just read the question again.
0.4 I cap.
Okay.
And 0.8 J cap plus lambda K cap.
0.4 I cap, 0.8 J cap plus lambda K cap. And we have to find the value for lambda. Since in this part, this A having cap over it, which means A is a unit vector. And we know magnitude of unit vector is just 1. So A mod will be equals to root under x component square plus y component square and z component square. And since A is a unit vector, so it will have magnitude as 1. So on squaring both sides, it will be 0.16, 0.64 plus lambda square. So lambda square equals to 1 minus, these two terms will combine to give you 0.80. So it will be 0.20. So lambda will be root and 2 point. Is it clear?
Yes, sir. Thank you, sir.
So in last class, we have started motion plane and I defined you till this part. Okay. Now there will be a question. If position vector t dependent is 2 times t cube I cap minus 4 times of t j cap plus 5 k cap. Find velocity and acceleration at t is equals to 2 seconds. Since we have r, which is position vector, so if you differentiate it, it will give you velocity. If you further differentiate velocity, it will give you acceleration. Just try to find it. We have r as this. So velocity will be dr over dt. In this r, we have 3 different terms along x component, y component, and z component. So we have to differentiate them individually. So it will be 2 as coefficient. T cube on differentiation will be 3t square along I cap minus of 4, t having exponential 1. So on differentiation, it will be 1 along j cap. 5 is any constant. So differentiation will be 0. 6t squared I cap minus 4 j cap. This will be velocity of particle at any instant. So if we put the value of t to be 2 seconds, it will be v is equals to 2 to 4 into 6, 24 I cap minus of 4 j cap. And if you have to find magnitude of velocity for this or speed, it will be root under 24 square plus minus of 4 square. Next, if you have to find acceleration, just differentiate this term. It will be acceleration is equals to 6 as constant. T square on differentiation, it will be 2 times of t I cap minus of 4, which is a constant term. So on differentiation, it will be 0. So you will get 12 times t I cap is equals to a. Now, if you put the value of t to be 2 seconds in this expression, you will get a is equals to 24 in x-axis or along x-axis. Is it clear, Mariam?
Yes, sir.
Safan, any doubt?
No, sir.
Done, sir.
Done, sir.
Sabita, done?
Yes, sir.
Okay. There will be a question in this part as if x is equals to alpha times t squared and y is equals to beta times t, then find speed of body at t is equals to 2 seconds. Try to find using the above concept. If you differentiate x component, it will define you velocity along x-axis, that will be vx. And if you differentiate y, it will define your velocity along y-axis. Then put the value of t to be 2 seconds and take the magnitude of them. First, differentiate this part. You'll get velocity along x-axis as dx over dt. Similarly, differentiate this part. You'll get velocity along y-axis as dy over dt. Now, if you have to find speed, which is nothing but magnitude of velocity, so it will be root of vx squared plus vy squared. We have to take combined magnitude. Okay, Mariam? Samira, just check your calculation. If you differentiate the first part, alpha is constant, so take it outside. T square on differentiation will be 2t. So if you put the value of t to be 2 seconds, you will get 4 times alpha is equals to Vx. Similarly for Vy, beta is constant. On differentiating t, it will be just 1. So Vy equals to just beta. If you put these two terms in this expression, you will get 4 alpha squared plus beta squared root under. So it will be 16 alpha squared plus beta squared whole under root. Is it clear?
Yes, sir.
So far, in it out.
No, sir.
You all have written till this part?
Yes,
Yes,
sir.
sir.
Yes, sir.
Safan, done?
Done, sir.
Okay. So this is all about motion in 2 dimension. Next is relative motion. Relative motion is if you have to define motion of a body with respect to some reference or some other body or some other reference, this type of motion is termed as a relative motion. Since for every motion, we have to first define about a reference from which all observations of these motional parameters can be calculated are termed as reference frame or reference body or coordinate system. Now we are assuming that reference itself is moving and we have to define motion with respect to that part. So the motion of a body with respect to other body or system is termed as relative motion. Now I'm defining you some of its formula. Suppose there is a body at this point, let's say A, and this is origin O, this is point B. So if we define its displacement from origin, that is displacement of A from origin, so it will be in this direction. Similarly, displacement of B from origin, so it will be from this point to this point like this. And now if you have to relate A and B only from this point to this point. So I'm defining you how to relate them. First, for O to A, displacement from O to A will be vector OA just 1 minute. Or you'll say vector OA is equals to displacement from O to A. Similarly, from O to B, it will define your displacement from O to B, and we have to relate A to B only. So it will be displacement on A to B. Now, if you want to combine these three terms, it will be AB is equals to OB minus OA. Is it clear?
Yes, sir.
Yes, sir.
So these are displacement. If we divide them by time, it will define you velocity. Just 1 minute. Okay. So we have to define velocity or relation between them. So we must take first a reference point from which we are calculating. So there is some relation related to velocity using these concepts. First is velocity of any object with respect to its own self will be always zero. Next, velocity of A with respect to B will be opposite of velocity of B with respect to A. So there will be negative sign in between. Is it clear?
Yes, sir.
Third is, if you have to define velocity of A with respect to B, which is already defined for some other reference, let's say with respect to ground or with respect to some other reference. So it will be velocity of A with respect to C, velocity of B with respect to C. If the reference point of both these two terms is from C point, so there will be a negative sign in between. And if you further reverse this orientation, it will be velocity of A with respect to B is equals to velocity of A with respect to C minus plus velocity of C with respect to B. I've just reversed this orientation using this concept. So there will be plus sign in between. So we have mainly 4 different relation for this relative motion. First is velocity of a body with respect to its own self. Second, velocity of A with respect to B. Is opposite of velocity of B with respect to A. Third is velocity of A with respect to B is equals to velocity of A with respect to C minus velocity of B with respect to C. And similarly this part. Is it clear till this part?
Yes, sir. Yes, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Sufan, Arslan, have you done?
Yes, sir, done.
Okay. Now I'm assigning first relative motion in one dimension. There is a problem. A train is going towards east at 25 meters per second with respect to ground. A monkey is running on it at 5 meters per second with respect to train. So find velocity of monkey with respect to ground. Towards east, towards west. So first of all, for any problem, depending upon the given part, use coordinate system to define their direction. So east is along positive x-axis, so it will be taken as positive. West is along negative x-axis, so it will be taken as negative. So in this first part, we have a train which is going at 25 meters per second with respect to ground. So it will be velocity of train with respect to ground. And since it is going towards east, which is taken as positive, so it will be plus 25 meters per second. Next is, there is a monkey which is running towards west with respect to train. So it will be velocity of monkey with respect to train in west direction. So it will be negative 5 meters per second. Is it clear?
Yes, sir.
Yes, sir.
Now we have to find velocity of monkey with respect to ground. So according to the above relation, we can write velocity of monkey with respect to ground is equals to velocity of monkey with respect to train and velocity of train with respect to ground. So in this part, we have train in this term and train in this term. So they are in opposite sense. So there will be plus sign in between. According to the last part or last formula. This term. Since you have A with respect to C and C with respect to B, then C and C will cancel out. So you'll get A with respect to B. Is it clear?
Yes, sir.
So I've just used this concept in this part to find velocity of monkey with respect to ground. So in this part, this is train and this is train. So these two terms will cancel out. So you get monkey with respect to ground. Now we have values for each term. Just put their values and try to find. Just simplify it. Good, Mariam. Good, Samaira. Just put the value of each term and simplify it. We have velocity of monkey with respect to train as -5 and velocity of train with respect to ground as plus 25. Just put them and simplify it. Velocity of monkey with respect to ground, with respect to train is -5. So it will be -5. Velocity of train with respect to ground is +25. So it will be 20 meters per second. And since it is positive, so it will be observed that monkey is going towards east at 20 meters per second. Is it clear till this part? Safan?
Yes, sir.
Sabita?
Yes, sir.
Okay. I'm giving you one more problem related to this. A police van is chasing a thief car at 30 kilometers per hour. Which is going at 192 kilometers per hour, and police van is chasing at 130 kilometers per hour. Then now policeman fired a bullet at 150 meters per second towards thief car. Find velocity of bullet with which it will hit thief's car. In this part, we have a police van which is going along this direction with some velocity, say velocity of van with respect to ground, which is 30 kilometers per hour. So multiply it by 5 by 18, it will be converted into meter per second. And there is a thief car which is going very fast along this direction at velocity of thief's car with respect to ground is 192 kilometers per hour. So just multiply it by 5 by 18 to convert into meter per second. Then policeman fired a bullet along this direction. So velocity of bullet with respect to police van is 150 meters per second. So we have to find velocity of bullet with respect to thief's car. So first, try to find velocity of bullet with respect to ground using these two notation. Just use velocity of bullet with respect to van and velocity of van with respect to ground. So use the sign what will be in this part. Then velocity of bullet with respect to thief's car with the velocity of bullet with respect to ground and velocity of thief car with respect to ground, and simplify it. I'm giving you one hint how to use the sign in between. Suppose you have to find velocity of bullet with respect to ground. And since you have given velocity of bullet with respect to van, so just write these two terms with respect to same reference as velocity of bullet with respect to van and velocity of ground with respect to van. So if velocity of each body will be defined from same reference, then there will be negative sign in between. Then now reverse the direction of the second part. So it will be velocity of bullet with respect to ground with respect to van. And if we reverse the orientation of this, there will be positive sign in between and you will get velocity of van with respect to ground. Is it clear? So here it will be positive sign. And in the second part, since the reference point of each two term are from the same, that is ground, so there will be negative sign in between. Now put the value of each term in these two expressions and simplify it. Mariam, is it your final answer?
Sir, velocity of bullet with respect to the thief car.
Okay, just check your calculation then. If you put all the values in this part to get velocity of bullet with respect to ground, it will be velocity of bullet with respect to van 150 plus velocity of van with respect to ground is 30 km per hour. So it will be multiplied by 5 by 18. Now put this value in this second equation. You will get velocity of bullet with respect to thief car is equals to velocity of bullet with respect to ground, which is 150 plus 30 into 5 by 18 minus velocity of thief car with respect to ground 192 into 5 by 18. Now just simplify it, you'll get your answer. Just simplify this equation. Good, Mariam. Good, Samara. Safan, have you solved? Sabita?
No, sir, I'm still doing.
If you further simplify it, you will get 150 plus 5 over 18. 192 minus 30, it will be minus of 162. So 18 and 9 times will be 162. So 9 into 5 will be 45. So 150 minus 45 is equals to 105 meter per second. Is it clear, Arslan?
Yes, sir.
So Fan, do you have any doubt in this concept?
No, sir.
Okay. Since in these two problems, I had just defined you to find velocity. But if you have displacement, velocity, acceleration, all of these terms, so how you will relate or apply formula? So whenever you have displacement, velocity, and time, you'll say time will never be relative. The rest of the whole term will be in relative motion or will be in relative. So using equation of motion, as we had v is equals to u plus a times t. So in case of relative motion, it will be v relative is equals to u relative times a relative into t. And for relative term, each relative must be defined within the same system. Suppose velocity of a with respect to b will be equals to initial velocity of a with respect to b, and acceleration itself would also be with respect to a and b. But time is independent of this particular relation, or you'll say time can never be relative. Time would be relative in case of speed of light or comparable to speed of light, which is beyond your scope of syllabus. Okay. So just you use take time to be non-relative term for your reference. Then next is S relative is equals to U relative into T plus half of A relative into T square, and so on. I'm defining with respect to one example. On a 2-lane road, car A is going towards east at 36 km per hour. Car B and car C moving in opposite of each other at 54 km per hour. When separation between AB and AC is 1 kilometer, driver of car B decided to overtake car A before C. So find minimum acceleration. Suppose this is your 2-lane road, first lane, second lane. There is a car A at this point, which is going towards east at 36 km per hour. Two cars, B and C, moving in opposite direction. Let's say at this point, car B moving along this direction, and at this point, car C in this direction, moving at 54 km per hour respectively. At this instant, separation of each car is 1 kilometer apart. So 1 kilometer in between first and second, and 1 kilometer in between first and third. Is it clear till this part?
Yes, sir.
So first we have to find time taken by A and C to cross each other. First, for A and C. As we have velocity of A with respect to ground is in east direction, which is positive x-axis. So it will be 36 into 5 by 18, that is 10 meter per second in positive direction. Similarly, velocity of C with respect to ground is in west. So it will be negative 54 into 5 by 18. So it will be minus 15 meter per second. And initial separation between A and C, you will say displacement between A and C is 1 kilometer. So it will be 1000 meters. So this is a relative separation between A and C. Since there is no acceleration between A and C, so you will say acceleration of A with respect to ground, or acceleration of C with respect to ground, or acceleration of A with respect to C. These all term is 0. So just use second equation of motion, for which we have to find velocity of A with respect to C. Velocity of A with respect to C may be defined as velocity of A with respect to ground and velocity of C with respect to ground. Both are defining with respect to same reference, so there will be negative sign in between. Now we have velocity and displacement. So using second equation of motion, you'll say S relative is equals to U relative into T plus half AT squared, where acceleration is 0. So you have S relative, you have U relative, then you will get time in between them. Samira, is it clear?
Yes, sir.
First, write it down till this part. Just 1 minute. Okay.
Done, sir.
Done, sir.
This will behave as initial velocity between A and C. Try to find this part, then put the value in this equation to find T. Good, Samara. If you put all the values in this part, as we have velocity of A with respect to ground is plus 10, minus velocity of car C with respect to ground is minus 15. So it will be 25 meter per second. If you put all the values in this equation, S relative is 1000, U relative is 25 into T. So from this, you will get T is equals to 40 seconds. Arslan, is it clear?
Yes, sir.
Okay. Now, the minimum time for B to overtake car A is 40 seconds. So we have to apply this for B and C, for B and A. Velocity of B with respect to ground is along east, so it will be positive. 54 into 5 by 18, so it will be 15 meter per second. So relative velocity of B with respect to A equals to velocity of B with respect to ground, velocity of A with respect to ground, both having same reference, so there will be negative in between. As we have velocity of B with respect to ground is 15, velocity of A with respect to ground is 10, so it will be 5 meter per second. And this velocity will behave as initial velocity, so it will be UBA. Now using second equation of motion, S relative is equals to U relative into T plus half of A relative into T squared. Both within the same reference, B with respect to A, B with respect to A, and B with respect to A. Just simplify it, you'll get acceleration of B with respect to A from this part. Put the value of T to be 40 seconds. U relative is 5 meter per second. S relative is 1000. as we have separation between them is 1000 equals to initial velocity 5, time is 40, half acceleration we have to calculate is 40 squared. This 2 will cancel out this. So if you simplify it, 1000 minus 5 into 4, it will be 200 is equals to 800 times A. So A will be 1 meter per second squared.
Done, sir.
Any doubt in this problem? Sabita?
No, sir.
Arslan? Safan?
Yes, sir.
You all have written?
Done, sir.
So this is all about relative motion in 1 dimension. Next is relative motion in 2 dimension. In which first problem would be Reaver and swimmer problem. Suppose there is a river which is flowing along this direction. Let's say along east with some velocity. Let's say u. So velocity of river with respect to ground is plus of u I cap. Now there is a swimmer which dives at some inclination with respect to horizontal at this with some velocity v at some inclination theta with it. So it will have 2 components. One would be along this direction and the other would be along this direction. So this will be v times cos theta and this will be v times sine theta. So if you write it in terms of vector, it will be velocity of swimmer with respect to river. So it will be v times cos theta in I cap opposite direction. So there will be negative sign plus velocity of sine theta along j cap. Now we have to define velocity of swimmer with respect to ground. So velocity of swimmer with respect to ground may be written as velocity of swimmer with respect to river and velocity of ground with respect to river. as both having same notation. So there would be negative sign in between. But we have velocity of river with respect to ground. So just reverse this orientation. So it will be velocity of swimmer with respect to river plus velocity of river with respect to ground. So you will get minus of v cos theta along I cap plus of v sin theta along j cap, and velocity of river with respect to ground is plus of u I cap. So on rearranging, you will get u minus v cos theta whole in terms of I cap plus v times sin theta along j cap as velocity of swimmer with respect to ground. Is it clear till this part? Mariam, any doubt?
No, sir.
Now we have to define some condition related to this. Since we have two terms, one is along x-axis and the other is along y-axis. So first term will be for normal dive. First, time taken to cross river. As we have width of river in y component, so each term will be individually defined along x-axis as well as y-axis. Only time will be common for both different axes. So t is equals to distance by speed. Distance and y-axis is w, and speed in y-axis is v times sin theta. So this will define you time to cross river from this end to this end. And suppose diver, your swimmer have made normal stroke. So theta will be 90 degree and sin 90 is maximum. So time will be minimum. So for minimum time or for normal stroke, theta will be 90 degree. So T minimum equals to W divided by B. Is it clear?
Yes, sir.
First, write it down till this part.
Done, sir.
Done, sir.
Done, sir.
Sufan, your turn. Arslan.
Done, sir.
Okay.
Done.
Now we have to define drift in position of swimmer. In this velocity, we have two components. One is along y-axis and the other is along x-axis. So in this x part, we have two components. One is u, that is velocity of Reaver, and second is v cos theta, that is component of velocity of swimmer. So if u will be greater than v cos theta, which means velocity of stream of Reaver is greater than velocity of component of swimmer, then it will shift or drift swimmer slightly away from its actual point along this path to reach at this point. So net amount of shift from actual path would be this term. Suppose u is smaller than v cos theta, so drift velocity or drift would be till this point. So let's say this is point A, this is point B, C, and D. So net drift will be equals to speed into time. We have speed as u times v cos theta, and time taken to move from one point to other is w over v times sine theta. This shift may be of three different types depending upon u and v cos theta. If u is greater than v cos theta, it will define u b to d. If u is equals to v cos theta, then there will be no drift or no shift. And if u is less than v times cos theta, it will be along the right side. So if u is greater than v cos theta, it will drift along the right side to move b to c. And if u is less than v cos theta, it will drift along left side. So it will be b into d. And the net distance from its actual path would be this much. Is it clear?
Yes, sir.
Yes, sir.
Now we have to define for this no drift. If u and v cos theta would be equal, so cos theta equals to u divided by v. So this is the angle at which you must strive to reach just opposite end. So time taken in this particular path, or it will be termed as shortest path, t is equals to distance by speed. So speed in that part is v times sine theta. If you break sine theta in terms of this part, you will get w divided by root of v squared minus u squared. So in this Reaver problem, we have to mainly define two different terms. First is time for normal stroke to cover or to cross Reaver, and time to cover shortest path for no drift. This and this, two terms. Just write it down. I'm giving an example.
Done, sir.
Done, sir.
Done, sir.
Arslan, Safan, you have written?
Yes, sir. Finish.
Yes,
Okay.
sir.
I'm giving you one remarkable related to this. A river is flowing toward east at 5 meters per second. A swimmer who can swim in still water at 10 meters per second dives into it. Find time first for normal stroke, second for shortest path. If width of a river is 1 kilometer. So according to the above situation, we have to relate this problem. So in this part, we have 5 meter per second, that is velocity of river. So it will be u is equals to plus 5 meter per second. And velocity of swimmer in still water, that is 10 meter per second, which is v. Width of river, w, is equals to 1 kilometer. So in terms of meter, it will be 1000 meter. So we have formula. Just put all this down and try to simplify it. In second part, you have to find also angle of dive. Good, Mariam. Good, Samira. In second part, we have to calculate time for shortest path and also angle of dive in this situation. Okay, Samira?
Yes, sir.
In first part, for normal stroke, T is equals to width of river divided by velocity of swimmer. In second part, for shortest path, T would be equals to width of river divided by V square minus U square. And this path, angle of dive would be U divided by V. Just put all the values in this part. If you put all the values in this first part, we have width of river as 1000. Divide by velocity of swimmer is 10. So this 0 and this 0 will cancel out. So you will get 100 seconds for normal stroke. For second part, width of river is 1000. Divide by root under V is 10 square minus U is 5 square. So 10 square is 100, 5 square is 25. So it will be 75 root under. So you may write as 5 root 3. 5 and 200 times divide by root 3. Or you may put root 3 as 1.7 and simplify it. Next, for the third part, if you find theta, we have U as 5, V as 10. So it will be 1/2. So theta will be 60 degree. But we have to define angle of dive with respect to flow of stream. So angle of dive with respect to stream of river, it will be 180 degree minus 60 degree. So it will be 120 degree. I'm defining with this diagram. Since we have calculated this theta, but we have to find this angle from this point to this point. So it will be 180 minus theta with respect to flow of river. Okay. Is it clear to all of you?
Yes, sir.
Arslan?
Yes, sir.
Safan, any doubt till this
No, sir.
part?
No.
Okay. Now, in this condition, if you put theta is equals to 180 degree, so motion of stream and motion of swimmer both would be parallel to each other. So you'll get net velocity of swimmer with respect to Reaver as u plus v, this only. So this will be the case of downstream. Similarly, if you put theta to be 0 degree, you'll get velocity of swimmer with respect to Reaver as u minus v or v minus u. So this will be the case of upstream. Just write it down.
Done, sir.
Done, sir.
Okay. So next thing in this relative motion is rain problem. This is east-west. This is north-south. And this is a vertical motion or vertical path. East, west, north, south. If rain is falling at some angle with respect to vertical along this direction, so it will be velocity of rain with respect to ground. And let's say inclination with respect to this is theta, for which it will have two components. One would be along this direction, one would be along this direction. Let's say A along this path and B along this path. And in this, a boy with umbrella or a man with umbrella is going towards east with some velocity u. If rain is falling at theta with vertical, so velocity of rain with respect to ground is equals to A times I cap minus of B times J cap, as B is in negative y-axis. In this situation, a man with umbrella is going towards east at some velocity u. So it will be velocity of man with respect to ground in east axis or east direction. So it will be positive u I cap. Now we have to take a relative of these two terms. First, write it down till this part.
Done, sir.
Done, sir.
Okay. So if you take velocity of man with respect to ground, it will be velocity of man with respect to ground minus velocity of rain with respect to ground. So you'll get U I cap minus, just 1 minute. Suppose I'm taking the reverse of it. Velocity of rain with respect to man. So it will be velocity of rain with respect to ground minus velocity of man with respect to ground. As we have AI cap minus of BJ cap minus of UI cap. So if you rearrange them, you will get A minus U in I cap minus of B times J cap. Now in this part, we have two terms. One is along x-axis and the other is along y-axis. This is x component and this is y component. So if you want to calculate theta, tan theta is equals to perpendicular over base. If you define with respect to diagram, we have base as P and perpendicular as A minus U. So tan theta will be equals to A minus U divided by B, this much. So this term or this theta would be of three different case depending upon value of A and U. If A is greater than U, so theta will be acute angle. If A equals to U, so this whole term would be 0, means theta will be 0. So umbrella would be along vertical direction. And if A is less than U, so this whole fraction will be negative. So theta will be obtuse, which means, let's say this is your vertical line. So in this part, if A is greater than U, so umbrella would be along this direction. At some inclination this, so it will be at this. Umbrella has moved towards west by this much amount of theta. In the second path, let's say this is your vertical line. So A minus U will be 0, so theta will be 0. So umbrella will be in vertical direction like this. Similarly, in third part, if A is less than U, then umbrella would be along this direction. This will be theta, so this will be theta, which will be towards east. So depending upon the value of A and U, we can define its inclination or inclination of umbrella with respect to vertical. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Done, sir.
On a rainy day, rain is falling vertically at 4 meters per second. So in this part, we have only vertical component, that is B. So A is 0 in this part. Now, a man with umbrella is going towards east with 3 meters per second. So U is 3. So find the inclination of umbrella he should hold in order to save himself. So you have to find theta and in which direction he should bend it. Try to calculate. We have A is equals to 0, B is equals to 4 meters per second, and U is equals to 3 meters per second. Just use the above formula and try to find theta. As we have tan theta is equals to A minus U divided by B. A is 0, U is 3, divide by 4. So it will be minus of 3 by 4. So you'll say it will be towards east. So tan theta will be 3 by 4. So theta will be 37 degree towards east. So this is third case in which A is less than U. Is it clear?
Yes, sir.
Sabita?
Yes, sir.
Okay. So this is all about relative motion in 2 dimension. I just left one topic in this chapter, that is circular motion, which I will define you after 6th chapter, that is after work, energy, and power. Okay. So let's stop here. In next class onward, we'll continue Newton's law of motion, that is chapter number 5. Okay.
Yes, sir.
Okay. And there is one announcement. I will take your Viva, for which you have to prepare till product of vector. Okay, Safan?
Yes, sir.
Okay then.
Thank you, sir.
Thank you.
Thank you, sir.